question 21, which is like a probability question. So in this question, you have Harold who tosses a nickel 4 times. We're given that the probability that he gets as many heads as tails is what? So this is a very like standard probability question. So again, I feel like the numbers in this case are really small. So one way you could do this is just list them out. Like, of course, I'm not going to do that here, but like the general idea is if you let H represent heads, T represent tails, you know that there are like a bunch of possibilities. You can get like H, 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 H. Like that represents the case when you get all 4 heads. You can get like H, 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 T. Means you get 3 heads and 1 tail. And you can list out, it turns out there would be like 2 to the 4, 16 possibilities and count, and you can one by one count which ones have more at least as many heads as tails. But of course, it's not the most efficient way to do the problem. So, maybe a better way to do the problem is like, if you're tossing the coin 4 times, and we want at least as many heads as tails, that means we either have to have 4 heads and 0 tails, we can have 3 heads and 1 tail, or we can have like 2 heads and 2 tails, right? These are the only like possible like number of heads and number of tails that will satisfy the original problem statement. Like you can't have like 1 head and like 3 tails, because then the number of heads won't be at least as many as the number of tails. So we can kind of like casework this out now. So like in this first case, if you have 4 heads and 0 tails, there's only one possibility, right? That's pretty obvious. You have to get like heads all 4 times. So that's only one way. Then for this case, when you flip 3 heads and 1 tail, how many ways are there for that? So the idea is if you have like 4 blanks, it depends where we put the T, right? If we put the tail like here, then the remaining 3 heads go here. If the tail goes here, the remaining 3 heads go here. So like instead of, you could list them out. It's pretty easy to list them out. Or like you can just say this is equal to like 4 choose 1, which is 4, right? Because 4 choose 1 represents like which of the 4 places are you going to choose to put the 1 tail in. So 4 choose 1 equals 4 ways to do that. And then if you have 2 heads, 2 tails, this is going to be 4 choose 2. Because out of the 4 blanks, you need to choose 2 of the blanks to put the 2 tails in. Like if you choose this blank and this blank, then you need to like put in tails there. And you can calculate 4 choose 2 is equal to 6. Again, you could just list them out. That's another possibility, but like this is a more elegant way to do it. So now remember the probability for formula, or the formula for probability, right? The formula for probability is going to equal the number of success divided by the number of possible. So we found the number of success here, right? The number of success, we found it came in 3 different cases. 4 heads and 0 tails gave 1 way, 3 heads and 1 tail gave 4 ways, and 2 heads and 2 tails gave 6 ways. So the total number of success is going to be 1 plus 4 plus 6. And for the number of possible, we're going to flip the coin 4 times, right? So, and each time you flip the coin, it can be a heads or a tails. So the total number of possible ways is 2 to the power of 4. So if you were to just do the math, you would get 11 over 16 as like the probability. And that would give us like choice E, which is like the correct answer. So just like a brief note, like maybe in this case, like they made the number like 4 pretty small, right? But it turns out like let's say they slightly modified the question and they said like Harold tosses a nickel 5 times, like instead of 4 times. Let's say he tosses it 5 times, and we wanted to know what the probability was that he got as many heads as tails, like at least as many heads as tails. Like I just want to briefly mention this is a very common kind of question. Like let's say if like instead of 4, what if the original question said like 5 times? So it turns out like this is a very like nice trick and common question. So the answer like for like the case where he tosses it 5 times would just be a half. So it turns out like whenever like Harold tosses the nickel like an odd number of times, like even if he tosses it like 999 times, the answer is still going to be a half. And the reason is because like you kind of think about it as like there's nothing special about heads and tails, right? Like heads and tails are kind of just like words. You can think of them as they're not like that significant. I could have easily asked the same question: what is the probability that he gets at least as many tails as heads? That would be essentially asking the same question. So we know that like those 2 probabilities have to be the same. So that means the probability has to be a half. So hopefully that made sense. If that didn't really make sense, like that, then it's fine. Like this is not like that important. It's just something interesting. But like in this case, when he flipped an even number of times, when he flipped it 4 times, that kind of changed some stuff. So, but like the general strategy for these kinds of questions is just like kind of list out, do the casework, and like just use this like probability like golden formula thing, right? It's always like number of success divided by the number of possible outcomes.